Welcome to this video on electricity, circuits and their components. We will explore circuits and their components, taking a visual journey from large-scale power generation to the everyday microcircuits in your pocket. Our world relies on an energy web that harnesses nature's forces. From hydroelectric dams to wind and solar power, these sources are transformed into electrical energy, powering everything from home lighting and appliances to our communication devices. We use two main types of electricity: alternating current, or AC, which comes from the power grid and changes direction, and direct current, or DC, which flows in one direction and powers our portable devices. To understand how these work, let's reverse engineer a simple flashlight. It consists of a lamp for light, a battery to provide power, a switch to control the flow, and an insulating casing to hold it all together safely. Inside the power pump, or battery, we find individual cells. For a circuit to function, we follow the rule of alignment. The positive terminal of one cell must connect to the negative terminal of the next. Placing them incorrectly will break the circuit. When it comes to the light source, incandescent lamps use a heating filament and aren't picky about polarity. In contrast, LEDs have no filament and require strict polarity. The longer wire must connect to the positive terminal, or they won't work. Electricity requires an unbroken path to flow, which we call a closed circuit. Current moves from the positive terminal to the negative. If a wire is disconnected or a bulb is fused, the path breaks and the current stops instantly. A switch acts as our gatekeeper. When it's in the off position, it creates an air gap that stops the flow. When closed, it bridges that gap, allowing the current to travel through the circuit. To help engineers communicate globally, we use standardized symbols for components like cells, LEDs, and switches. These symbols allow anyone to read and build electrical blueprints accurately. By using these symbols, we can create abstract circuit diagrams. You can trace the path of electricity from the battery's positive terminal, through the switch, to the light, and back to the negative terminal. Materials are split into two categories: conductors, like copper, which allow electricity to flow, and insulators, like rubber or plastic, which block it to keep us safe from electrical shocks. Safety is paramount because the human body is an excellent conductor. Never handle frayed wires or touch switches with wet hands. Always respect the power of electricity to prevent severe injury or death. In summary, a complete energy loop requires a power source, a conductive path, a control switch, and a load like an LED. Together, these components transform energy into the light we use every day.